Alright, this is 1.6. In 1.6 we're going to be dealing with inequalities. Okay. Also interval notation is going to come in handy for this section 1.6. So do freshen up on interval notation because we're going to be using it. Okay. So the first little warning that we have here is to always remember to flip the inequality sign when multiplying or dividing by a negative number. And why is that? Why is that? Well, let's just think about a simple little example. Imagine that I had something like 5 is larger than 2. I mean, that's obviously true. So this is saying that 5 is greater than 2. Okay. Now imagine that I multiply both sides by negative 1. Okay, so if I multiply both sides by negative 1, I end up with negative 5 and negative 2. But now which one's bigger? Which value is bigger? Negative 5 or negative 2? When it comes to negatives, the negatives that are closer to 0 are actually bigger than the negatives that are further to the left from 0. So it turns out that negative 2 now is larger than negative 5. That is sort of the justification as to why we need to flip the inequality sign anytime that we multiply or divide by negative 1, by a negative. So keep that in mind. So we said a little bit about interval notation. We use parentheses for whenever we do not include the endpoint A. We use a bracket to indicate that we do include the endpoints. And then there's also this business of set builder notation. So remember that these wiggly brackets just indicate that it's a set, and then you give me the elements. The elements in this case are called x. This vertical line, just sort of read it as if it just said such as. So x's such as x is bigger than a and less than infinity. All right, let's get into some exercises here. Let's get into just some of the inequalities that we gotta solve. Okay, good. So solve each of the following, represent the solution set with both interval and set notation, and also graph the solution set. So we gotta do 3 things. We gotta do a few things. Solve the inequality, and then express the answer or the solution in interval notation, set notation, and also make a little sketch of the solution. Okay, let's just get into one of them. Although, I mean, at this point, what I would tell you is stop the video, see if you can solve or actually answer these 4 questions here. The last one is not really an inequality. Well, I mean, it's going to be made into an inequality. The last one asks about domain. But the first 3 are just some inequalities to be solved. So pause the video, see if you can tackle them, and then let's compare answers. Alright, so let me begin with the top left one. So I'm going to solve first. Just remember, anytime that you add or anytime that you multiply or divide by a negative, the inequality sign flips. So keep that in mind. So I'm going to begin by doing plus 2x plus 5 plus 5. Okay, so 3x plus 2x, that's 5x. And then less than 5 plus 6, that's 11. And notice that right now I haven't really done any division or multiplication. All I've done is add or subtract. So my inequality sign stays the same. Alright, so then I guess I'm going to divide by 5. And my solution then looks to be x is less than 11 over 5. Okay. So the interval notation for that is going to be negative infinity to 11 over 5. That's the interval notation answer. The set notation answer would be x's such that x is less than 11 over 5. So that's the set notation. And now the sketch of the solution, well, it looks something like this. Let's pretend that 11 over 5, I'm going to put a little circle right there. That's 11 divided by 5. 11 over 5 would be a little bit more than 2. And, well, the solution is everything that's less than 11 over 5. Alright, so hopefully we agree on that. That one wasn't too bad. We did not have to multiply or divide by anything negative, so our inequality sign did not flip. Next one. Let's try the next one. So same idea. I'm going to begin by adding 7x. I'm also going to add 4. Notice that I did not multiply or divide anything, so my inequality hasn't flipped. So 13 plus 4, that's 17. 17, and my inequality still is the same. And then 10x plus 7x, I guess that's 17x. And so then let me divide by 17 both sides. I divided by something positive, so the inequality doesn't flip. So this becomes 1 bigger than or equal to x. All right. So the interval notation here, let me just move this up just a notch there. There we go. So the interval notation that we want here is, so think about this. It's saying that 1 is bigger than or equal to x. It's a little weird to understand. I mean, we're very used to reading things left to right. But sometimes you gotta make the effort and think about things right to left a little bit. And so then what's going on here is that I have values that are less than or equal to 1. So things that are less than or equal to 1. X's that are less than, so this guy is less than or equal to 1. Okay, so it's going to be negative infinity to 1 with a bracket. That's the interval notation. The set builder notation would be x's such that x is, well, less than or equal to 1. And the graphical representation of this solution, well, it looks something like this. Oops. Put a little circle right there. Oh, no, right now I do not need a circle. Actually, it's a solid dot. It's solid. And that's 1. And it's everything that is to the left of 1, including 1. That is my graphical representation of my solution. Okay, so hopefully so far so good. Let's try the next one. I'm going to begin by distributing 4x into things. And then doing some other multiplications. So the first thing I have is 4x squared minus 8x is bigger than 4x minus 2 times x minus 3. So think about the algebra that's just happened here. We haven't really done much anything other than distribute. I distributed this 4x, so 4x times x, that's 4x squared. 4x times negative 2, that's minus 8x, good. Bigger than 2 times 2x, well, that's 4x. 2 times negative 1, that's negative 2. And then I still have to multiply by this x minus 3. So think FOIL here. So this is going to become 4x squared minus 8x bigger than. Now I gotta do the following. I gotta do 4x times x, 4x times 3, and then 2 times x and 2 times negative 3. That's what I gotta do. So that's going to become 4x squared. Why? Because 4x times x is 4x squared, and then 4x times negative 3, that's going to become minus 12x, and then negative 2 times x, that's minus 2x, and the negative 2 times negative 3, that's 6 plus 6. Okay, now it's a matter of combining like terms and getting x squares with x squares, x's with x's, and numbers with numbers, and solving for x. So the first thing to notice here is that if I subtract 4x squared, well, then those cancel. That's gone, so that's gone. What's going on with my colors here? Sorry. That's gone. I'm supposed to be using red, but I don't know why blue is coming out. So then I have negative, come on. I have negative, that's strange. You can see that it's highlighted as a red, but it's writing in blue. I don't know why that is. That's okay. Negative 8x, there we go. Negative 8x is bigger than, and then I have 12x minus 2x, that's minus 14x plus 6. Okay. Then the next thing I'm going to do is I'm going to add 14x to both sides. I'm going to add 14x to the right and to the left of the inequality. Okay, so negative 8 plus 14, so negative 8 plus 14 is going to be 6. So I'm going to have 6x is bigger than 6. Just for a second, if think about what just happened there, I added 14x to the right hand side, so the negative 14 and the positive 14 cancel, and then I added 14 to the left hand side, so 14 minus 8 is 6. I haven't divided or multiplied by anything negative yet, so that's okay. And the last thing to do is divide by 6, and I end up with x is bigger than 1. Okay, so things that are bigger than 1, the interval notation for that is 1 to positive infinity. The set notation is x's such that x is bigger than 1. And the graphical representation of this set, I guess, looks something like this. So 1, and it's things that are bigger than 1. So things to the right of 1, not including 1. All right, so far, hopefully we are all in the same page. Last exercise here. I gotta find the domain in interval notation of this function. So I am dealing with a square root, and what we said is we do not want to have negatives inside the square root. So I want the part that's inside of the square root to be positive. So what does it mean to be positive? It means that you're bigger than 0. That's what it means. To be positive means that you're bigger than or bigger than 0. Ooh, sorry. There's always a delay with my computer. Technical difficulties. I cannot even write anymore. Or can I? Give me 1 second here. We'll find the domain of this thing. What you're going to have to do is you're going to have to make an inequality. You're going to say 1 minus 5x is bigger than 0. But I wanted to write down some things here in the margin just to give you something to work with, but my computer is not cooperating. go. I think I'm getting something done. All right. So what I wanted to say is this, that if x is bigger than 0, that means x is positive. X is negative if x is less than 0. So let's keep that in mind. If you are bigger than 0, that means that you're positive. If you're less than 0, that means that you're negative. All right, so right now we want the inner part of my square root to be positive. So I'm gonna do this, 1 minus 5x, and it's okay if it's 0 too, because the square root of 0 is 0. So I'm gonna set this to bigger than or equal to 0. So I'm gonna subtract 1, I'm gonna subtract 1. Okay, and then the next thing I'm gonna do is I am going to divide by negative 5. Both sides get divided by negative 5. But be careful at that point. Since we're dividing by something negative, the inequality sign is going to flip. Okay, so that's my domain. My domain is all the values that are less than or equal to 1/5. So in interval notation, that goes something like this. Negative infinity to 1/5 with a bracket. Okay, so hopefully we agreed. If you work these examples out, we all agree on the answers. Let's move on. Compound inequalities. So it's two inequalities together. So it's two inequalities joined by the word and or the word or. So and means an intersection, an overlap. Or means the union. You just put everything that's in two sets together. So for example, here we have negative 3x, negative 3 is less than 2x plus 5, and 2x plus 5 is less than 7. So this is a compound inequality, and sometimes this compound inequality can be put together into a single compound inequality. Notice here that the 2x plus 5, 2x plus 5 over here, we can sort of sandwich it together. So I have 2x plus 5 is less than or equal to 7 and bigger than negative 3. These two inequalities represent the same thing. All right, so let's see. Let's try to solve some compound inequalities here. Let's first focus on the first two. So I want to solve this compound inequality, graph the solution set, and write also my answer in set builder notation. And the same thing for this other compound inequality. So let's see. Pause the video, see if you can figure out parts A and B. Right, so hopefully you pause the video and you already worked out parts A and B, and right now we're just at a point where we're going to compare answers. Again, the same rule about flipping the inequality is just that now we have two inequalities to be dealing with. We have two inequalities to be dealing with. If you multiply or divide by something negative, both inequalities are going to flip. So just keep that in mind. So let me begin solving the first one, the leftmost one. So I'm going to say minus 5, and minus 5. I'm subtracting 5 from, in a sense, this thing has three parts now. The leftmost, the middle, and the rightmost. Okay, so that becomes negative 8, less than 2x, less than or equal to 7 minus 5, that's 2. And then I'm going to divide everything by 2. So that's negative 4, less than x, less than or equal to 1. Okay, so that is the solution to my inequality. Let's make sense of what is the interval notation for this inequality. Well, it's this. It's saying it's all values, all numbers that are less than or equal to 1 and bigger than negative 4. So in interval notation, it looks like this. negative 4 comma 1 with a bracket. That would be the interval notation solution here. The set builder notation would say this: x's such that x is less than or equal to 1, bigger than negative 4. They represent the same set. Okay. So hopefully that worked out for you. Let's think about the next one. Let's solve that inequality. So in this inequality, I'm going to have to be working two inequalities at the same time. And that's okay. Just remember that if you multiply or divide something by a negative, the inequality signs flip. So I am going to begin by adding 5. So then I have this: 2x is less than or equal to negative 2, or then I have 2x is bigger than 6. Okay? And then I'm going to divide both of these inequalities by 2. Okay, so then that says that x is less than or equal to negative 1, or x is bigger than 3. Okay? And okay, let me finish this one, and then I have something to say about the previous one, but let me finish this example. Okay, so we're here: x is less than or equal to negative 1, or x is bigger than 3. Okay, so let's think about each little piece here. X's that are less than or equal to negative 1. So then that means negative infinity to negative 1 with a bracket. Now let me think about things that are bigger than 3. Well, that would be parentheses 3 to positive infinity. And then we said that this or, what it is, it's a union. Yeah, it's a union of sets. Now let me say something about this previous one. I guess what we could have also said here is that it's x's such. Well, let me not make a mess here. Using my eraser always causes me problems. So what I wanted to say here is that it's going to be x's such that x is bigger than negative 4, and then we could have said and x is less than or equal to 1. So I kind of want to say that in the set builder notation, the interval notation though, the interval notation is fine though. What the heck is going on? Come on. Sorry. Can I go back to using my pen? There we go. Okay, whatever. Let's see. That's okay. Let's see. Let me see if I can use at least my. Go back to red ink. Yeah. Okay, so what we can say is this: it's x is such that x is bigger than negative 4 and x is less than or equal to 1. We could have said that. That would have also been okay. But we kind of managed to just put all of this together in just this compound inequality. Alright, so hopefully we get the same answers for these problems. Let's try the two last exercises in this section. They are word problems. And we're going to have to think about them a little bit, but I think we can tackle it. Okay, so we have Erica, and she paints houses, and Erica can be paid in either of two ways. There's plan A, where she gets $250 up front and then $10 per hour. Or there's plan B, where she gets just $20 per hour. Okay, so let me kind of make a little equation for each plan. Or not an equation, but like an expression, I should say. So for instance, this one would say 250 plus 10n, where n is the number of hours that she works. This other one would say 20n, and I guess let's agree that n is number of hours worked. Okay, and so now the question becomes, suppose that a job takes n hours. Okay, so that's good. For what values of n is plan B better for Erica? So how many hours does Erica have to work so that plan B becomes more profitable, becomes bigger? So how do you set that up? Pause the video, see if you can figure it out, see if you have an idea. Alright, so what it's going to require is this. So plan B is the 20n. I want 20n to be bigger than 10, or well, let me 10n plus 250. That's what I want. I want to figure out, I want to make sure that the plan B is better than the plan A. So then let me solve this inequality. So 20n minus 10n, that's 10n, bigger than 250. Let me divide everything by 10. And so then that says that n is bigger than 25. Okay, so then turns out that plan B is better if Erica works more than 25 hours. So that's how many hours she has to work so that plan B gives her more money. If it's less than 25 hours, then plan A is better. I guess it just depends on how long the job is going to take. All right, so hopefully we're okay with this problem. The last one. Last problem in this section, and last problem in this whole chapter. Okay, so let's see. We have Jalen. She wants to invest $12,000. I wish I had $12,000 to invest. Part of those $12,000 is going to be invested at 4% simple interest, and the rest is going to be invested at 6% simple interest. So she's going to split her $12,000 into two pieces. I don't know, they're not equal pieces. One part she's going to invest it at 4% simple interest. The other part she's going to invest it at 6% simple interest. And the question is, what is the most that she can invest at 4%? So what's the most that she can invest at 4% and still be guaranteed at least $650 in interest per year? Interesting question. Pause the video, see if you can set it up, see if you can get something working. Okay, so what we have first of all is I'm gonna say an X amount of dollars is going to be at 4%. So if Jalen puts X amount of dollars at 4%, then she has to put 12,000 minus X at 6%. So let's just first agree to that. So she's going to put an X amount of dollars into the 4% interest, and she's going to put the remaining amount of money, 12,000 minus X, at 6%. and we want the interest to be at least $650. At least. At least means bigger than or equal. So I'm going to set up a little equation. It's going to look something like this. 0.04x. So that's the interest that I get at the 4% plus 12,000 times, 12,000. Oh gosh, I need to erase that parentheses, but my computer is going to be stupid and not going to allow me to use my eraser. I don't know why. I don't know what's going on here. It's usually not the case. So what I'm about to write here is, so we have 0.04x plus, and then I'm going to say 12,000 minus x, and then I'll close my parentheses. That's what I want to write down. If technology cooperates with me. Why? Now I cannot even use my pen or my eraser or anything. I'm sorry. There we go. Come on. Erase. Sorry about that. I don't know what's going on. On the next videos, I'll try to figure this out because this is annoying. I'm sorry. I need to be able to use all of the tools here so that I can Alright, I guess it doesn't matter. We'll see. Can we continue at least with color now? No, we can't. Sorry. There we go. Minus x times 0.06, and that should be bigger than or equal to 650. Ooh, finally. Sorry about that. So think about what's going on here. What we're saying is a certain amount of money at 4%, that's the interest right there. The remaining amount of money at 6% should be bigger than or equal to 650. And now I just gotta solve this equation here. So oh, come on. Oh, please. So now it's a matter of solving this inequality. It's just a matter of solving this inequality. I'm gonna, well, let me see if I can finish solving it here for you so you can sort of see the intermediate steps. There's probably going to be at some point where we're going to be dividing by something negative. So just keep in mind that if you divide by something negative, the inequality sign flips. Come on. So 0.04x, and then you would have to distribute the 0.6 multiplied by 12,000 and then 0.06 times x. And if I am not mistaken, 0.06 times 12,000 is 720. Let's see, come on. What's going on with this? Eventually, what you should get out of this, if I'm not mistaken, so here I'm going to leave out some of the details. Sorry, just for the sake of time, is that x should be less than or equal to 3,500. Again, you're going to have to multiply this and multiply that, collect like terms, and solve for x. And remember that if you multiply or divide by a negative, the inequality sign flips. And so I guess what we can conclude here is that Jalen needs to invest at most 3,500 at 4% to guarantee to guarantee 650 in interest. Okay, sorry about the technical difficulties here. My computer is being a little bit slow. Hopefully you can fill out the details here of this inequality. And that's it for this section. That is it for this section. And that's also it for this chapter. I'll see you in the next chapter. Thank you.